Our first speaker is Libor Peltan, who will be talking about long-distance AXFR versus database replication.
Good morning. This is Libor Peltan from CZ.NIC again. I will be talking yet again about authoritative DNS operations. In the last talk, I was talking about the signing pipeline, and this time it will be about the Anycast. Because big authoritative DNS operations need to operate the Anycast of the secondary DNS services that are actually answering the client's queries wherever they are. But transferring the fresh zone contents to those remote locations can be tricky, and this is the topic of my talk. So big authoritative DNS operations either operate a huge zone like a big TLD, or they operate many tiny zones, or a mixture of them. So for the huge zone, we usually try to transfer the fresh zone contents updates via the incremental zone transfers, but it can always happen for various reasons that they fall back to the full zone transfer. This is where the problems can begin. And for many zones, there are questions about how they are actually transferred, if through one connection or many connections, or how it works. So the traditional way was to use the DNS zone transfers, but the alternative can be using the database backend. The database backend has various use cases of all kinds, but in this talk I will be specifically using database backend only for the transferring the zone contents over long distances. For example, PowerDNS is known to support database backends, usually in the way that an incoming DNS query to the authoritative server causes or may cause a requery to the database to fetch the data, its cache, and so forth. But the node-DNS approach is different. It loads the whole zone from the database at once, like if it would load from a zone file, and then answers the queries from memory. So I used this node-DNS plus Redis backend as the test scenario for the database replication. I was also considering to measure the same for PowerDNS with MySQL backend, but then I was reluctant to publish measurement results of something that I'm not really able to configure well. I was afraid it would be unfair if I configure PowerDNS in the wrong way, and then the results would be unrepresentative. So the setups that I used, I prepared 3 setups for comparison. There is the first setup with the traditional full zone transfer, AXFR, possibly using zone transfer over TLS. Then there is the alternative setup to be compared, which is database replication, which means that both the nodes, geographically distant, have their own local database backend stored there, and the over the distance data transfer happens through database replication. And the third, slightly weird setup is made the way that there is only the database backend at the central node, and the remote authoritative server loads remotely over the distance the data from the distant database backend. So we would like to compare those 3, and we would like to compare those 3 setups in 2 major use cases. First of them being a large zone, which I choose the Swedish TLD, having 8 million records. There are TLDs that are larger than that, 10 times, but it's fairly easy to understand what will happen if you use 10 times bigger zone. And as a second case, I used 100,000 of tiny zones, which will show how the zone transfers behave when you have many tiny zones. Of course, your own setup can be a mixture of those 2 or even different, but it's not difficult to infer what will be the results like in your case. So I must admit, I did not actually test the transfers over the actual real distance. I just asked our CZ.NIC admins what are their experiences with the most remote locations. For example, to Latin America, they told me that there is a there is this latency of roughly quarter of a second, and there is a packet loss of 2 from 1,000. So I used some kernel magic to simulate this distance in the local lab. So to the results. For the big zone, the Swedish TLD, the results were pretty similar. Like it took roughly half an hour to transfer the zone over the simulated distance, whatever means I used. With the replication backend, it was slightly slower, but not that much. That would be like a significant difference. But for those 100,000 zones, there were only like really significant differences. For example, the traditional AXFR took 20 minutes, but if I enabled zone transfers over TLS, it was like more than 3 times slower. But with the Redis replication, the proposed alternative, this was really fast. It was like, I was even surprised if it's correct, if I not made any mistake, but no, it was half a minute. And the third setup was slower than the traditional AXFR, but not that terrible as zone transfer over TLS. So let me analyze this. For the big zone, it looks like that the time consumed by the transfer over the distance only depends on the volume of the data that are actually transferred. There is always like one TCP connection that needs to transit all the data. And the TCP connection suffers the latency and it suffers the packet loss, therefore it is slow in general. But you have to only wait proportionally to the volume of data until the data are transferred. So, for example, if there is some compression on the AXFR, it helps slightly. If there are some overhead in the database nodes, somehow in the database data, it's slightly slower, but in general, these are minor differences. And also, in the case when we were using this Redis replication setup for transferring many zones, it was actually the same case. Like the data inside the database were serialized regardless if they belong to one big zone or if they belong to countless tiny zones. They are serialized into one TCP connection, transferred, and also the same effect happens. So the overall time only depends on the complete volume of the data. On the other hand, with the many zones transferred over AXFR, there were some problems in the DNS the zone transfers protocol itself and also in not DNS architecture. It happens that there is a number of workers configured, which can be configured arbitrarily, but I configure 50 workers, and it happens the way that each of the workers simply takes one zone to be processed from a queue of zones to be processed and processes it down. So it means that if processing of the single zone takes one round-trip time to the remote location, it will take this quarter of a second to process a single zone. And if there are 50 workers, you can only process 50 zones in a quarter of a second, and therefore it leads the final time. If there are more round-trip times to be done for each single zone, it's even worse. For example, if the TCP connections were shared, so it used one round-trip time per zone, and it took those 20 minutes. If there was a TLS overlay in Node.DNS, it means that for every single zone, a new TCP handshake is made despite reusing the TLS session. It took 3 round-trip times per zone, and it was even slower. So my recommendation could be to increase the number of workers because they are only waiting for the round-trip time for the answer to come back. So you might, if you have really many zones, you can even go to thousands of workers and see if it improves. But in general, it always is good also to consider the database replication case. So the overview for the big zone, the time depends on volume of data transferred. for many zones, the database replication really helps compacting those zone updates into a single stream and transfer it over long distances. And I would be really glad to see similar results for Power DNS or any other software that uses database backend as well. Thank you.
Jeff Houston, APNIC. I am curious about the implicit use of SSH going on here, that your tests invariably have an encrypted session, TLS, right? To what extent is SSH the real problem? If you used, for example, HPN SSH, it was likely on a large transfer over a long delay, you would find radically different performance because SSH is slow. Or if you ditched that and went to QUIC and relied on QUIC for your end-to-end encryption, again, you might find vastly superior performance. So is this really an issue of AXFR, IXFR parallelism? Or is this more of an issue around, I need to move data from A to B, I'm trying to find a transport protocol and system that actually works optimally inside the context of what I have. You know, if I was doing this, I'd be doing HPN SSH over BBR or QUIC right away. And I bet you I'd be faster than your numbers for that very reason. I don't think it's a DNS problem is where I'm heading. Thanks.
Partly agreed.
Yeah, Peter. Hi, Peter Lexus, Power DNS. I had a question. Did you do any TCP tuning on the NOT front? So bigger window sizes or other tricks like that to increase the throughput, maybe over the bad connection?
Short answer, no. I tried to stick with defaults in both the TLS, both the TCP stack in Linux and the NOT DNS as much as possible in order for the results to be representative.
Okay, thank you.
Yeah.
Hi, Tamás PCH. This is also a question which I was thinking for some time because we have many sites, and what I realized, and which is probably not in your talk, is AXFR actually, so incremental zone transfer, and that I think this is really, really important. And on our systems, I was working really hard and actually looking at the logs and stuff to make sure that AXFR is always on and the files are always available, etc., because just that you have the incremental option really speeds things up. And I think this is also the reason why you recently added options also to NOT, to calculate the differences of the zones you get. So you can do AXFR like downstream to downstream clients, for example.
Of course, as I said in the beginning, you should always try to do AXFR incremental transfers if possible. But for my talk, it was not that interesting because the AXFR is always small or almost always small unless you do ZSK rollover at once. So it would actually look that the big zone happens to be one small zone which is transferred immediately. So if you have many zones, and regardless if you are using AXFR or IXFR, the number of zones will matter because there will be always a tiny transfer per each zone. Yeah.
The only reason why I'm bringing this up, because once you have the system running, it's really quick. But if you have a database, that's a different metric. So
yes, but the database can also operate in an incremental manner. So the stores, the replications, and the loads from the database are made incrementally every time.
Okay, that's fair. Okay.
Johan Stenstam. Once upon a time, this is basically a story from a long time ago. I really appreciate this because I've spent some time on it about 15 years ago. And my test case, or rather my situation, was that I needed to transfer a bunch of large TLD zones to faraway places. And I only had AXFR and IXFR to deal with. And IXFR is fine once you have the first version of the zone, but you need to start with an AXFR, and that sort of timed out, didn't work, timed out again, and all sorts of problems for about a month. At the time, 15 years ago, the fallback for me was to use BitTorrent.
Great.
Okay.
So, thank you.
Thank you, Libor.